Write the following expression in terms of only sine theta or cosine theta. So there are actually two ways to approach this problem. I'm going to do the long way first and then the fast way second. So the long way is to recognize this as cosine of the sum of an angle. So we can use our sum identity. So cosine of alpha plus beta is equal to cosine of alpha times the cosine of beta minus the sine of alpha times the sine of beta. And then plug in alpha equals theta, and beta is this 2k minus 1 times pi. So we get then cosine of the first angle is just theta, and then cosine of the 2k minus 1 times pi, and then minus sine of the angle, the first angle, theta, and then times sine of the 2k minus 1 times pi. Now we need to simplify this expression here. So notice that when we have the 2k minus 1 in each of these, we're assuming here that k is an integer. Probably should have said that, where k is an integer. So 2k minus 1 then, if you take an integer multiply by 2, you get an even number, and then subtract 1, that's going to be odd. So 2k minus 1 times pi is an odd numbered pi. Now if we think of the unit circle, the odd pi's are over here on the left. This is pi, and then back here is 2 pi, 3 pi, 4 pi, 5 pi. So all the odd pi's are over here on the left. So that's the location that we're looking at. So sine of that angle, no matter what odd numbered pi you have, that's equal to 0. That means then that this whole term is gone. That's 0. It also means that this cosine of an odd pi is always negative 1. Negative 1. And so our final answer, we get negative 1 times cosine of theta. So that's just negative cosine of theta. That's the long way to do this problem. The short way to do it is to just go back to this original and recognize again that if 2k minus 1 is an odd number, we have cosine of theta plus an odd number pi. Well, if we just look at the unit circle and look at any angle that we have, call that, okay, that theta, adding an odd number pi will throw us to the other side over here, just straight across. And so we know that this is cosine theta, sine theta. If you go straight across, okay, the x-coordinate's going to be the negative of that. That's negative cosine theta. The y-coordinate's also going to be the negative sine theta. And so then we can see that if I start at theta and I add an odd number pi, that puts me at this place right here, whether I add 1 pi or 3 pi or 5 pi and so on. And so then the cosine of that angle is negative cosine theta. And so that gives us this answer as well.